Okay, so we are going to jump in and we are going to talk about kind of section 4.4 and 4.5 together, which is going to be on naming branched alkanes and isomers. Now, there's a little bit of section 4.5 that I'm going to cover actually in the 4.2 video. I apologize for the skipping around with this. This is just something that a way of presenting it that makes more sense to me. But in any case, all right. So we talked about in section 4.2 how, just for example, this would be propane, right? By the way, has a formula of C3H8. This would be butane. What about this compound, though? This compound is, we look at it, this has 1, 2, 3, 4 carbons. This would still be C4. It's going to be H10. But do we call this butane? Or really, is this the same compound as this? No, actually, it's not. All right. So, by the way, this is C4H10. Also, these compounds have different melting points, different boiling points. They are not the same compound, but they have the same molecular formula. So, we call the relationship between these two compounds isomers. Isomers are compounds with the same molecular formula, but different structures. All right. So we know we call this one butane. How do we name this one? Well, what we actually do with this is we look at this and we say, what? Okay, we've got 1, 2, 3 carbons bonded here in a row. So that's propane. 3 carbons in a row is propane. But we have this extra carbon hanging off of it. It's a single carbon, so that's what we call a methyl group. This is methyl propane. Same deal. If I go out to this one's going to be methylbutane. Now, what if I look at this compound versus this compound, right? These are both going to be methylpentane. But they're not the same compound. So here's how we do this. Here's how we handle this. We are going to start numbering at the end closest to a branch coming off. So let's look at this one. Let's number 1, 2, 3. 1, 2, 3. We can number either way. See where we end up with a lower number when we get to something hanging off. And that's going to be 3-methylpentane, right? This one's going to be, let's number it 1, 2. Now we know that that's going to be correct, but if we numbered from this direction, 1, 2, 3, 4, this one's going to be 2-methylpentane. Now, interestingly enough, following that rule, if I draw this compound, this is still going to be 2 methylpentane. No, that's a little scrunched there. Remember again, we number from the end closest to where something's hanging off of it. Also, the more practical answer to that is that these are two-dimensional representations of a three-dimensional compound. And so they're free to move around, contort everything else in space. All right. Let's extend this out and look at a few more examples, though. All right. Let's say that we have this compound. All right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we can all agree, hopefully, that this is a hexane. But what do we have hanging off of it? We have this, which is ethyl, right? So this is going to be ethyl. Ethyl hexane, where is it? 1, 2, 3. 3 ethyl hexane. Now, how about this one? We have 2 methyl groups hanging off of this. So, this way, this is a pentane, right? 1, 2, 3, 4, 5. We have 2 methyl groups hanging off of it. This is methylpentane. But because we have there are 2 of these methyl groups, we call this dimethylpentane. That should all be one word. Now, where are these methyl groups? We still have to say that. So 1, 2, 3, 4. 2, 4 dash dimethylpentane. Right now, I would not ask you an exam question where we have 2 different substituents, but let's look at how we would handle that if we did. It would be okay, so this one's 1, 2, 3, 4, 5, 6. This is hexane. On carbon 2, we have a methyl group. On carbon 4, we have an ethyl group. Now, we do these in alphabetical order. So this would actually be 4 ethyl dash 2 dash methyl hexane. Right. Now, our last thing too, we could extend this to cyclic compounds. It says this is a cyclohexane with an ethyl group hanging off of it. I would call this ethyl cyclohexane. Now, I don't need to number this one because every position on here is equivalent. But if I have this, now this would be 1, 2 diethyl cyclohexane. I'm going to run out of space again, but there we go. So that's how we name branched alkanes.